Ice cores are really critical to an understanding of climate science. They have the most pristine archive of information that we can look back to for long-range patterns. And so today we tried to build on the excitement of this polar work. Then we did a hands-on activity so teachers would get a better idea what kinds of data can come out of an ice core once research has begun. So what the teachers were actually doing in this activity was modeling an ice core. So starting by understanding how snow forms differently under different conditions, they use simulants for different kinds of snow. Sugar for summer snow, salt for winter snow, which looks a little differently, and then pepper for things that fall out of the atmosphere, such as volcanic ash. So what we saw was them snowing, building the layers of an ice core inside a graduated cylinder. They can begin to count up the annual layers and look at the observable properties and count back in time to this year of 1816. So that was the first part of the activity. But then there's what can't scientists see in an ice core, and this is where the really dramatic data comes out. And so there was a whole data set from Greenland and a data set from Antarctica on volcanic eruptions that occurred back in the time period of this activity. And so teachers were able to graph out where did these eruptions happen, when did they happen, how prolific were they, and begin to do some critical thinking about what could have happened back in 1816. Were these volcanic, the data that they saw related to this cooling of temperatures that caused the year without a summer? And so it's a neat activity that sort of gives them the physical properties and then the chemical properties of ice cores and leaves them with a feeling for how important this research is and how much we can learn from them.